So what we're going to do in this section is we're going to take all of those common functions from the last one and we're going to talk about transformations. So we're going to first go through horizontal and vertical shifts, and then in the next section we'll talk about other types of transformations too. So we're going to start with going through the types of shifts. So basically you're going to have a starting function. What you do to find that starting function is you ignore all of the constants that are there. Do you have an x cubed? Do you have a square root function? Do you have an absolute value function? What shape are you starting with? Then what we're going to do is we're basically going to add or subtract a value of c somewhere in that equation. And so we're going to assume that the c is a positive number. What I want you to kind of remember throughout these transformations is that when it's affecting the y, it's doing exactly what you would expect it to do. When you're dealing with x, it's often doing the opposite of what your brain wants to think. So the very first type of transformation we could have is that you tack on a plus c on the very outside. So this means I take the absolute value of x and I add 5 on the outside. What that tells you to do, because it's not directly attached to the x, it's impacting the y values. So when I think of plussing something in the y direction, it's going to move that original graph up c spaces. If I subtract a value, and again, this is on the outside, it's not attached to x, which meaning it's affecting the y. The negative version of y is moving something down. So this is going to move our original graph down c units. So these two things are called vertical shifts or vertical transformations because they're affecting the graph in the vertical direction. For these next two, I'm attaching this value of plus c to the x. So it's actually going to do the opposite of what you want. You would think x plus c would move it in the positive x direction. So you would think that would mean here to the right, but it's actually going to move it to the left c spaces. When I have x minus c, again, you would think that negative would be this direction, but it's going to be the opposite, and it's going to move this to the right. And then these two transformations are called horizontal shifts. Okay? So x is always the opposite of what our brain thinks that it should be. Now, the order to apply these shifts isn't going to matter too much in this section because moving it left, up, right, up, down doesn't matter which one you want to pick and choose first, but it is going to matter in your next section. So what I want you to do is think of your order of operations, no matter what you're doing these. What that means is I've got to start inside parentheses first. So inside parentheses mean I'm applying horizontal shifts first. So the order, you're going to always start with moving this graph left to right if that shift is there. You're always going to end by moving it up or down. Okay. So let's start with the graph of the absolute value function, and then we're going to apply this transformation where we have a minus 2 on the outside. So again, this is not attached to x. This means we're going to shift it down 2. So our starting graph is if we ignore this constant, we're going to graph y equals the absolute value of x. There are no horizontal shifts because I have nothing attached to x. So I don't need to worry about that. But then this minus 2 tells us to shift down 2. Okay? What I like to do is I kind of ghost sketch stuff in. And when you have multiple transformations, then I'll do multiple graphs. For here, since I just have the one transformation, we're going to draw the one graph. So I want to start by graphing the absolute value function. And again, you don't have to be super precise with all of the points, but I am going to at least keep track of one important one. So our original absolute value function goes through 0, 0, And this is the point that I'm going to keep track of. Okay? Let's make this a nice dotted one. So if I graph this function, it's that V shape that cuts right in half. What I need to do now is I need to take this graph and I need to shift it down to, so the point that was at 0, 0 gets moved to 0, -2. And then from there, I still have exactly the same shape. Okay, so this would be our graph of g of x, which equals the absolute value of x minus 2, right? And now that I have the graph, I can go ahead and find the domain and range just using that. I have no problematic x values, so our domain is all real numbers. But now our range has been impacted. The starting y value is -2, and then I continue upwards forever. So the range is -2 to infinity. So now let's do this next one, which is still going to be the absolute value function. And I still have a -2, but now I'm attaching this directly to my x. So this means I'm impacting my x, right? So we're going to start with the same function. If I ignore that constant, I've got the shape of my absolute value. And then this -2 tells us we're going to move it in the x direction. And because it's minus, you would think that would move it to the left, but it does the opposite. It's going to move it to the right too. And then there's no vertical shifts. Okay. So again, I have this single transformation, so I'm just going to draw a single graph for this. And I'm going to go probably 4 in each direction. So our starting graph again goes through 0, 0 and has that V shape. And then what I want to do is I want to move this to the right too. So let me keep track of that same point. We start at 0, 0. When I move that to the right too, it's going to go through the point 2, 0 instead. And then our graph gonna look something like this. The number one question I often get is, why does it do the opposite for x? And so basically, because I'm impacting the x, I'm trying to see what number do I plug in that gives me the same y value that I had before. So in this case, for this expression, when I plug in x is +2, that would be the absolute value of 2 minus 2, which is the absolute value of 0. And so that point that was at the origin now gets moved to 2, 0 instead. Okay. So we still have to find the domain and range, but again, domain, no problematic numbers. The only thing that has issues are square root functions. And then our range has not been affected from the original. The starting y value is 0, and then it continues to positive infinity. So we got a few more examples of these. Let's now try this one, which we have 2 different numbers, so we have 2 transformations. Again, first thing I want to do is I want to figure out my starting function. So ignoring all of those +2, +3, the graph we're beginning with is x squared. And now we do have 2 transformations. So again, I want to start with the ones inside the parentheses. So the first transformation affects the x. It's +2. You think it would be positive, but you're going to actually shift it left 2. Okay. And then we've got this +3 on the outside, so that's not attached to x. It's impacting the y. And it does what we would naturally think it does. +3 would be up 3. Okay. So I have 2 transformations. I do want to draw 2 different graphs here, knowing that I'm going to have to shift it left and up. So I'm going to kind of keep most of the stuff in the top quadrant. Okay. And I'm going to go out 1, 2, 3, 4 in each direction. And maybe 5 here. Whatever I can fit in on this graph. Okay. So now that we have our pictures, again, I'm going to start by just sketching in our starting graph, and we're going to do that in dotted lines. So we graph y equals x squared, which is our U-type shape. And I'm going to keep track of the point that goes through 0, 0. So our first transformation is we move it to the left 2. So this point would move to -2, 0. And then we would have this V shape. So this one is the graph of y equals x squared. If I want the equation of this graph, I've only applied the one transformation, so it is x plus 2 squared. Okay. Now for the next one, if you do want to go sketch this in, you can. If you're comfortable just moving it up, feel free. Just for completeness, I'm going to go sketch what we're starting with. So that was just moving it to the left 2. And now I want to move it up 3. So my new point that was originally at the origin goes through -2, +3. And then has this overall shape. So this would be our graph with both transformations applied. And then from here, gotta find that domain and range still, and we're using that last graph that I just drew to find that. The domain is still everything, no problematic values. And for our range, our starting y value is +3, so it goes from 3 up to infinity. So we're almost done with these examples. Got one more, and then we're going to kind of switch it up, and we're going to actually find the equation of the graph. So for this last one, if I ignore those constants, the graph we're going to begin with is our square root function. And again, we have two transformations. So I got to start inside stuff first. So that means I'm working with what's attached to x. And so this first transformation where I subtract 3 would be moving it in the opposite of what you want. So it's not negative side, it moves it to the right 3. And then we've got this -4 on the outside, which is a vertical, and that moves it exactly as you want. That moves it down 4. So I've got two transformations. We're going to draw two pictures, and we're going right and down. So let's mostly stay over here. So let's go out 5 in this direction. We'll go up 4. And then I definitely need to go down 4. Okay. And I'm going to cheat, and I'm going to copy and paste this over, because that's a little bit easier for me. And so we start with our graph of the square root function, which just looks like this. And it goes through the point 0, 0. First thing we need to do is move it to the right 3. So this is now at 3, 0. And it still has the same shape. This would be just that single transformation, so it is the square root of x minus 3. Now I need to take this graph, so I'm going to go sketch it in on our second picture. Okay. And now I want to move this down 4, so we just move it down here to 3, -4. But then it still has that same overall shape. So this would be the graph with both transformations applied. Okay. And so again, domain and range, got to find both of those. Here we have a square root function, so it is very particular. So our starting x value is +3. So the domain is actually from 3 to infinity. And you can kind of check yourself. If you tried to plug 2 in, that would be square root of 2 minus 3, which would be the square root of 1. Doesn't work. So I did actually graph this correctly. And then for our range, our starting y value is -4, and then we continue upwards forever. So the range is from -4 up to infinity. So the very last thing we're going to do is we're going to go ahead and find the equation that defines the given function. So we're given the picture of the graph. We have to figure out first, what is the function that we're dealing with? And second, what transformations have been applied? So for the very first one, if I take a look at that shape, this is the function y equals x cubed. Okay, but normally y equals x cubed goes through 0, 0, and then looks like this. So what happens is we've taken the graph of y equals x cubed and we've actually gone down 2 units. Okay. So if I want the equation for this, g of x, to indicate that we've moved the cube function down 2, is we just subtract 2 on the outside. Okay. For part B, if I look at that shape, it is our square function, which normally goes through 0, 0. And so what we've done is we've actually moved it left 1 and down 2. So this is the graph of x squared that's gone left 1 and down 2. So when we want the equation of this graph, I definitely am impacting the x. So I'm going to have x plus something or x minus something. To indicate that I go left 1, definitely need a 1 here. You would think it would be negative, but again, it's the opposite sign. So this is x plus 1 on the inside. And then down 2, we just put a minus sign on the outside. So in the next section, what we're going to do is we're going to talk about other types of shifts too, in combination with these. And again, that order is going to matter. We're here, the order really didn't, but getting in that habit of applying stuff in a particular way is going to be beneficial for you.